So what we're going to do, thank you, buddy. Turn this on. Negative 15,500 plus 17,000 is.
I got 15.
You got what now?
1,500.
Yep. So what'd you get up here on this one?
Let's see. 3,100. 6,150.
Okay. So it says state the domain of this function from 0 to 5. Because we're only going to look at finding the value of a large during the first 5 years of use, right?
Okay.
So our domain's 0 to 5, right?
Okay.
Now, let's sketch graph. What is the range of the function? Okay, so let's do this. So the range of the function is, well, it was how much after 5 years? 1,500. So it would be from 1,500 all the way up to 17,000. Now, does that make sense?
Why is it to 17,000?
How much did it cost when they purchased it?
Okay.
See, if you plug in 0 right here, right there for t, then your initial, because it's a linear equation. So the y-intercept 17,000. That's when time equals 0, right? That's how much they paid for it.
Right. Okay. Okay. Yeah, that makes sense.
So, and then that's range. So let's go here. It says, let me grab this real quick. After how many years would the copier only be worth 10,000? Round to 2 decimal places. After blank years, the copier will be on this. Well, what you're looking at is, let me grab something real quick, and it's this equation is what I want to grab. So we'll take that, cut. All right, so now they're giving you an output of 10,000 equals negative 3,100 t plus 17,000. And all you're doing is solving for the input now.
Okay.
So that's minus 17,000. So that's 7,000. That's negative 7,000 equals negative 3,100 t. And of course, what you do is you just divide by negative 3,100. And then I got, because those are two negatives, it'd give me a positive, right? Which is what I want anyway, because time is always in positive. It said 2 decimal places. Well, I got time to equal 2.2581. And then if I'm going to put that in the 2 decimal places, then that's going to be 2.26 years, right?
Right.
Yeah.
Okay. Now, what would you do as far as graphing that?
All right, so let's look.
What do they want you to use?
Well, the first thing that you're going to use, let's go here, is you're going to use 17,500, right?
Because that's your 0.
That's right. So I could use, well, I just drew all over that. So let's go a dot. And then you could pick another dot. It was what, 3,100? About like that. Yeah. And then a line.
Oh, okay.
So You're just, you got 17,000 at time equals 0, right? You could
Right.
just, you got a dot at 5, you got a dot at 3.5 that you've already found inputs for. So the graph portion of it, just do your best on it because it's
Okay.
probably going to give you fits.
Okay. That's good. Okay. Thank you.
Yep. All right. Let me go here. Get out of that. Yeah. So, all right. So, Ben or Aaron, do y'all have any?
Yeah, I got one. Can you hear me?
Yeah. Mm-hmm.
Okay, okay. Thank you for holding this. It's you know, it's time out of your free time, so thank you.
Yeah.
Um,
Yeah. We do this every Sunday.
all
So,
right. What I'm looking at is section 5.1, question number 20.
okay. So let's go here. And this is video, and I'll put them up on help session within Blackboard. 5.1. And it's problem number what? 20?
20. Yeah.
Okay. Oh, okay. Um, yeah. I have to cut your microphone off there. All right. So let's look at this problem real quick. Ethan wants to fence 3 sides of a rectangular exercise yard for his dog. The 4th side will be the house. He has 180 feet of fencing available. Find the dimensions that will enclose the maximum area. Well, let's think about this. So 3 sides are rectangular, and then, well, I guess we could do the fence is parallel to the house. The fence is perpendicular to the house. Okay, so let's just grab me a shape real quick. Where's my shapes at? No. There they are. So this is a house, right? And we have 180 feet of fencing. So what we're going to say is we're going to let this be X, and we're going to let that be X, and we're going to say that this is 180 minus 2X. Okay? So find the dimensions that enclose the maximum area. Yeah, okay. So any questions about how I came up with that?
No, I think I'm following you here.
Okay, so area is length times width, right? So we have X times 180 minus 2X. So, okay, let's think about it. The 4th side is the house. So we have X and X, 180 minus 2X. Yeah, okay, that'd be right. So we'd have 180X minus 2X squared, right? That would be our area. All right, so what we want to do now is I want to go negative 2X squared plus 180X, right? And if we're going to look at what's going to give us our maximum area, then what we want to do is basically find our vertex. So we would have what? Negative b over 2a. So that's really negative 1 times the b over 2 times the a. So a is negative 2, b equals 180. So we're going to plug those in. And then let's see. That's that. And then that's 2. That's really negative 2. So that's negative 180 over divided by negative 4. So what does that give me? That's 45. So that would be my vertex. That's my H. Yeah. So these right here would both be 45. And that right there would be 90. So the fence parallel to the house is 90 feet, and the fence perpendicular to the house is 45 feet, and the area of the yard is 90 times 45. What's 90 times 45? 90 times 45 is 4,050.
Okay, well, that helps me a lot. I guess part of it is drawing out a picture that would really help me.
Yeah, yeah. I had to get the area because that's really what we're looking at, right? And then I just found the X value of the vertex because the H really didn't. I mean, the H would have been, let's see, if I did 180 times 45 minus 2 times 45 squared. Yeah. Even if I took 45 and plugged it back into here, I still get 4,050. So if I took 45 and plugged it into that X and to that X to find the K value of the vertex, I'd still get this answer.
Well, I don't think I'm too worried about this anymore, but are we going to see something like this on the test?
Well, the test has groups of questions. So I don't know. Luck of the draw. I don't know, but I'd be prepared. I mean,
okay.
Yeah, every problem that's in the homework that has that's liable is subject to be on the test. So that's how these pool of problems are set up in categories. You know, they may have 3 of them that are the same type of problem, and let's see, maybe you get one of them, and then somebody else that's taking the test gets the other type of problem, but it's over the same content.
Yeah.
So, yeah.
Okay. I sent you an email as well. 2 questions in it. Can I ask you them here now?
Yeah. Got them right there.
Yeah.
So, you need to take calculus eventually. What kind of calculator do you need for that class?
Yeah.
Well, it really depends on if you're going to take. Well, you got to take 1113 first. So you're taking the pre-calc, right?
Yeah. I'm thinking 2 years down the line or something. You know?
I don't know. It just depends on how what professor wants to use. If I was going to do it, I'd probably have a TI-84.
Okay.
You need some kind of really good graphing calculator. And if I was going to do that, I would get a TI-84 plus CE. That's the color edition. so that when you graph multiple lines, they're in color and you can see them as opposed to a monochrome type thing. So you'll need it depending on how much. The final going to be open notes. We'll have a list of equations. There's a formula sheet that's up on your up in Blackboard already, and it says under final exam, and there's a tab that says final exam. It's got the final exam, it's got the solutions for the final exam review, and plus it also has the formula sheet.
Where are you?
That's up in Blackboard.
Oh, in Blackboard. Okay.
Yeah, and all the videos and the blank teaching notes are up there as well. I put them up in Blackboard some probably about a month ago, I guess. We couldn't get the vehicle that I was putting them in the website to work out, so I just stuck them in there. So, but there. Let's see. Aaron, do you have any? You're next.
Yeah, I have a few actually.
All right. Well, let's go. Talk to me.
On 4.2, question 4.
Okay. The table below resembles the table from an intro. Okay. The rows of the table give us ordered pairs. Okay. Use any two ordered pairs from the table to derive the equation for F in terms of C. Oh, okay. Oh, okay. So what you're doing is you're going to have to write the equation of Fahrenheit is what you're going to derive, right? So let's look at this, because it's not as bad as what you think. You've done it, but so here we go. This is X, right? And here's Y. So we've got an ordered pair. So what we need to do is we need to find slope. So we're going to take and we're going to say, okay, here's change in X and here's change in Y. So it should be constant because it's a linear equation. So yeah, these are all going up by 25, right? So let's look what these are going. 77 minus 32 is 45. And then let's take 77 plus 45, yeah. So what we're doing is this. So the slope equals 45 over 25, right? And you know that if you were to simplify that, that would come down to 9/5. Okay. Now, so you've got, you basically are like this. Fahrenheit, F of C, Fahrenheit with respect to Celsius, is 9/5 X plus 32, because this is the y-intercept right here when your X equals 0, and that's what that is, right? So that's what you got to derive right there, and that's how this equation come about.
Okay, yeah, I got you.
So
I had a hard time figuring that.
you didn't have to use point slope form because they gave you the X, not the X, the y-intercept, right? Because you're writing it in, let me write it like this, y equals mx plus b, right? So you got slope and y-intercept. So let's go here to see what else they're asking you. Use the equation to find the Fahrenheit temperature that corresponds to Celsius. So when it's 80 degrees Celsius, how much Fahrenheit? So that one is just 9/5 times 80 plus 32. And let's see. So we got 9 divided by 5 times 80 plus 32 comes out to be 176 degrees Fahrenheit. So this is Celsius, right? And I should have put a C there, but that should be a C, not an X, because I said F a C. So that's what you got. So that was let's see, go here. 144 plus 32, right? It's 176. So not bad. It's been just a little bit. We've been all over the map when it comes to writing equations. So different things. So just kind of keeping your skills up. We're doing that. So hold on for a second. Yes. All right. Let me go back.
On the equation part,
Mhm.
I just put in 9/5 x plus 32, and it said it was wrong.
Okay, hold up. Hit that reverse.
The 68. I mean, well,
Oh,
I did when it's 80 degrees. Mine was 20 degrees Celsius, and it came out to 68 Fahrenheit, and that was right.
do you know why? When you put 9/5 x plus 32, it said wrong?
No.
Because you got to say 9/5 c.
Oh, okay.
Yeah, that's why. They want it in terms of F and C.
Okay, I got you. Yeah, that's right.
Yeah.
I got you.
Yep. Okay. Let's go back up. Let's see. Amy, what you got?
Mine is from 5.1. It's just number one. I kind of just want to get refreshed on how to do that. I was looking at my notes. I'm still a little confused.
Oh, okay. So here we go. We're going to be using just like what we used to find the maximum area. Okay, so that's what we're going to do. So here we are. We've got it. It's y equals a x minus h squared plus k. So they're saying rewrite the quadratic in standard form and give the vertex, right? But we really call x squared plus 4x plus 3 standard, and then we call this over here vertex, right? That's just
Right.
what we do. So we've got like the vertex is h comma k. Now, when you plug the vertex in, it's got to change signs. But when you get to this one, just kind of know that that's not going to be the case, because do you see how they hard coded that negative in right there?
Uh-huh.
Okay, so just be mindful of that, okay?
Okay.
That's going to be different as opposed to writing the whole equation out like you normally would. All right, so what we've got to do here, A is 1, B is 4, right? So there's a way that you use H to find H, is use negative B over 2A. So what we're going to do is we'll do negative 1 times 4 over 2 times 1. That's negative 4 over 2, which is negative 2, right?
Yes.
Okay, so that's what's going in here.
Okay.
Okay, now that's an X. We call it H, but it's really an X value, because really that H and K is the same as X and Y in an ordered pair. But we write it H and K because we have a Y here and a X there, right? And we don't want to, when they done this, they did this in the conic section. So this is where all the H and K's come from, because you have H and K's for circles, parabolas, and hyperbolas, right? And ellipses. So, all right, so we know what the H value is. All we got to do is plug it back in here. So we're going to take this equation, x squared plus 4x plus 3, and we're going to say, okay, that's 1 times negative 2 squared plus 4 times negative 2 plus 3. And I'm going to say that's what? 1 times 4 minus 8 plus 3, which is 4 minus 8 plus 3 equals, what is that, negative 1? That'd be negative 4 plus 3. Yeah, it's negative 1, right? So that would be a negative 1 here. Now, so they want the vertex, which would be negative 2, negative 1, right? Because that's really what H and K is here, right? Now, this little value is A, and A happens to be, guess what? 1. And that's it. That's all you got to do.
Okay.
So anytime they want you to go from what I would call standard form in the ax squared plus bx plus c over into vertex form, what we traditionally call it, then you use this equation right here. And you go, that really, if you're thinking about it, that really is the beginning part of quadratic formula, right? You see this? So that's really, that part of it right there is really the x value for the vertex. So okay. So that's where that comes from. All right.
Okay.
All right. You're welcome. Ben, what you got? You still with us? Let's see if he's still with us. He said step away for a second, but Ben, you still there? Well, maybe he'll come back. Aaron, I'll go to you next. What you got?
I've got on 4.2, question 7.
Okay. Yeah. All right. Here we go. What you have is this. You have two ordered pairs here. Okay. So you got to make sure you understand you got two ordered pairs because they gave you two different scenarios. Flying lessons cost $646 for 8 hours and $1,425 for a 20-hour course. Both prices include a fixed insurance fee. So write an equation for the cost of flying lessons in terms of the length, H, in hours, right? Find the 2 points, H, comma, C, given the problem, and then write the equation through those 2 points, right? So here we go. So that's really 8, 645. That's an ordered pair. And then, of course, 20, 1425. And how I find slope, I do this. I say change in x and then change in y. So 8 to 20 is a change of 12. It's up the number line, so it's a positive. And then 645 up to 1425, I think, is 800. That 800, yeah. No, it's 18. It's 1425 minus 645. 780. So that's 780. And so we got slope equals change in y over change in x, which is 780 over 12, which should be 65. So the slope is 65, right? And that's really 65 over 1. If you think about that, the y values are in dollars and the h value is in hours. So that's really $65 per 1 hour, right? We call that a unit rate when the denominator is 1. Now, so we've got to write an equation. So if we're going to write an equation, so we're going to y minus y1 equals, because we'll have a y-intercept here, m times x minus x1. And we're just going to substitute them in, right? I'm going to pick, I like the small numbers, so we're going to pick those, and that's going to be my x and y. So I'm going to go y minus 645 equals 65 times x minus 8. These, note that because it's y minus, when you plug them in, they're going to change signs. So if they were positive coordinates, they would become negative, right? And if they were negative, then they would become positive. So just kind of make sure you're aware of that. And then we're doing like what we done at the beginning of the semester, which is we got y minus 645. So this is just kind of hanging out until I distribute it, right? So it's 65x. And if I think 65 times 8 is 520. But that is a negative 520. And then last thing we've got to do is we just got to add 645 over to the other side. And we'll get y equals 65x plus, so 645 minus 520 is 125. So before you even get up in the plane, it's going to cost you $125, and that $125 would be the insurance fee, right? Because if you think about it, this 125, that right there is actually the y-intercept, and that's when x equals 0. So if you think about it, 0, 125, at 0 hours, it costs $125, right? So kind of makes sense of what we got. Now, I can't put it in y equals, so it's going to be cost equals 65h plus 125. So make sure you put it in terms of h and c, and you should be okay. So again, if we got to write an equation, we need a point and a slope, hence the point slope form, right? And that's what this is right here. So should be okay on
Gotcha.
that. Yep.
Yeah, I would have never put them in those points first, and then I definitely wouldn't have remembered to put the h. I would have put x and kept getting it wrong.
Yeah, and that's why I reviewed the test, because you get so ingrained at x and y's, and you do the math correct. It's just and it would count it wrong, So just try to give you back everything you got. So, all right. So let's see. Ben, you still there? You said you had to step away, so I'm just checking before I go back to Amy.
Yeah, I'm still here.
All right. Do you have another one you want to see, or because I went to you and I didn't get anything, so I skipped you and went there, and so I'm coming back to you before I go back to Amy.
I'm gonna keep asking questions. I'm just sitting back and trying to take it all in before the test.
Oh, okay. All right. Amy, what you got, girl?
If you want to let Erin go through hers, that's probably going to help me out too. I don't have any specific ones right now.
Okay. All right, Erin, you're in the driver's seat, girl. So let's go.
You guys don't hate me. I've got quite a few. I don't.
No, I don't hate you. It'll help.
This is a big help. Thank you.
Yep. All right, girl.
I'm having problems with 7.1, question 5, and 8.
Okay, so let's go 7.1. Okay. Question 5. Man. Okay. Can't remember what I did with this problem as far as there. All right. Here we go. It says solve by graphing, right? So you can do it one or two ways. You can take each equation and you can put it back in slope-intercept form, which means I got to get my x to the other side. So this is a positive x. When I move it over, it would be a negative x. Then I'd have plus 3, right? And then I would divide everything by -1. So that would give me, for the top one, y equals x minus 3, right? So I'd start at my b is -3, and then my slope is 1/1, right? So if I did that, I would start at -3, and then I'd go up 1, right? Up 1/1 every time. Okay, so I'm just kind of putting dots there and there. So Now, you could also, because it's in standard form, you could have used X and Y intercepts if you wanted to. You remember how we did that back in the beginning of the semester, where you covered up the Y when you wanted the X intercept, so the X intercept would be 3, right? And if you look at this, there's 3, right? And that's okay. It's probably easier to do the graphing by slope intercept form, because then you can get more dots as opposed to just 2 points, because you actually have the slope. So for this one, we will move the x over to the other side, so that's y equals negative x plus 1. And because my coefficient's a positive 1 on my y, I'm done. So my slope is negative 1 over 1, and my y-intercept's 1. So when I graph it, I'm going to start at 1. I'm going to go down and to the right 1. So down 1 over 1, down 1 over 1. And you can see that they intersect right there, which would be 2, negative 1. So that's how you do that one.
Gotcha. So much easier now.
Well, I think we did one like this, but I'm not sure. Yeah, we did one of these in class, and we talked about the x, y intercepts. But now thinking about it, slope intercept form is probably going to be the easiest for you to really get the most benefit from, because see, you've got all these dots down here. So, all right,
Can you use elimination for that as well?
Do what now?
Can you use elimination for that as well?
You could, but then all you would find is the point of intersection, and they said graph it. So you'd get the answer correct. Right here it says point of intersection, or the solution is boom. I'm not sure. Can you put in? Well, let's see something. What did I say? The answer was 2, negative 1, right? Yeah. So let's just see if it'll take it without me. 2, negative 1, and submit. Well, it took 2 of them. It just didn't take the graph, right? So, and the graph was a third. So you got 2/3 of the problem right, and only a third of it wrong. So yeah, you're gonna have to graph it. But let's see. Yeah, draw. And then here, right? There. I guess you could do that, and then let me submit it now. Yeah, when I do that, then I'm good. So yeah, you got to use the graph. So sorry. All right, so what we got?
I also have number 8 on there. It was weird for me just because when I plugged the numbers back in, it matched the top number, like it matched the top equation, but it didn't match the bottom one.
Okay, well, this one actually says solve by substitution. I'm not going to solve it by substitution, and here's why. Both of them are in standard form. So I'm actually going to use elimination. So just kind of be aware of that. So I've got, and I'm going to use elimination by addition. So that means I have to get both of these to be the same number or the same coefficient in front, but opposite signs. So what I'll do is I'll multiply the bottom one by negative 1. So that would give me, here's the top one. So if I do the bottom one by negative 1, that's negative 1x minus 2y equals negative 4, right? And then when I add them, I eliminate my x's, which is what I'm wanting. Then I get y equals 1, which is great because then I ain't got to do anything else. I know what the y value is. And then you either plug it back into the top one or the bottom one, doesn't really matter. And then I go x plus 3 times 1 equals 5. So x plus 3 equals 5, and then minus 3, x equals 2. So what I've got is my solution is 2, 1. So my solution is an ordered pair. So that's what I want to make sure I do there. And the only thing that they wanted was 2, 1, right? So they're in standard form. Just do elimination. That's the easiest. If they had it like here, I'll show you. If they took this equation right here and they had it written like x equals negative 3y plus 5, and then they had x plus 2y equals 4, and they said solve by substitution, then I would do substitution all day long because I would have it already solved in terms of one variable. Doesn't matter if it's x or y. It just has to be solved in terms of one variable. But because these are in standard, just do it by elimination. So much easier. Okay.
Yeah, I did the exact same process, it looks like, but I had like my problems were x minus 5y equals 23, and the other one was x minus 3y equals 13. And the solutions I got were 13, negative 2, and it went into the top one fine, but the bottom one it didn't.
Okay. It should. Do you only have to? It should work in both of them because it's a point of intersection. So I'm not quite sure. I'd have to work.
Yeah, I have no idea what happened there.
Yeah, I'd have to work it out, but yeah, that's what I would do on this one. So, all right.
I know my process is right, so I can do a different equation if I need.
Yeah, and look, some people just do elimination by subtraction where they say the top one minus the bottom one. I multiply it to get it to be inverses of one another so I can add them. And that way I don't have to worry about it. So just depends on, excuse me, just depends on how your teacher taught you. I strictly just teach elimination by addition. So, all right, what you got next?
7.1. On question 4, I got the value wrong, but I got the minimum or maximum and the axis of symmetry right, but I can't get the value right.
For this? 7.1? For question number 4?
Oh, 5.1, my bad, 5.1.
Okay, I was like, ooh, okay. Let's go back here. And then axis of symmetry is going to be x equals the h value, right?
Yeah, it seems like I have no problem on the axis of symmetry. It's just the value I kept getting wrong.
Huh. Oh, it's a maximum. And then, oh, it's got to be an ordered pair. Unless they're wanting just the y value. So let me do it.
I wrote it down as an ordered pair, and it keeps coming out wrong.
Then just put the y value. And I'll show you what I mean by the y value.
Yeah, I just did that and it was right.
Okay, that's sometimes they'll this is going to be a minimum because it's opening up, right? See that A is positive, so it's a smile. There's your smile, it's opening up. So the y equals k is the value. So when they say value, then axis symmetry would be x equals h. So when they want that y value, the maximum, sometimes they do it as just the y value, which would be the k that you're solving for, or sometimes they'll want you to actually put us on ordered pair. But so if the order pair doesn't work, then your Y value would be just fine. But since they say value, then they're just looking for the Y. You want me to work this one, or are you okay? Was
Oh
it just
no,
syntax?
yeah, I'm okay. It was just
All right.
yeah.
Okay. All right. So, all right, let's go back. What you got?
Number 8. I can get the domain right, but I get the range wrong.
Oh, okay. So you still, all you got to do is find the vertex, okay? So the domain for these are always going to be negative infinity to positive infinity. So just be mindful of that. That's kind of like a give me. But when you do the range, what you have to do is find the vertex, right? Because this thing is opening up. So this vertex happens to be the lowest Y value. Okay. And the highest would be infinity. So let's go find the vertex. So h equals negative b over 2a. So we got a equals 2, b equals 8. So we have negative 1 times 8 over 2 times 2. So that's negative 8 over 4, which is negative 2. Then we're going to plug that back into here to find my k value. K equals 2 times negative 2 squared plus 8 times negative 2 plus 12. So that's going to be 4. 4 times 2 is 8, and that's going to be negative 16 plus 12. So that's 4. So my vertex is actually, this little point right here actually is negative 2, 4, right? So if you think about it from a range standpoint, it's from 4 to infinity because it's opening up. And then the domain would always be this. And the range for a quadratic will always have one side a parentheses, the other side a bracket, guaranteed. Now, it may start off with a bracket, then the other side has to be parentheses because you're either looking at infinity or negative infinity. But it's the k value of the vertex is basically what you're looking for. You had to solve for it on that. Okay. Does that help you a little bit?
Yes, sir.
Okay. All right. I should have asked you if you could copy that. Or
I'm all right.
okay. All right. So which one?
Number 10 or 9 and 10 actually. I'm having a trouble drawing the parabolas or you know.
Okay. So let me grab this. So again, this happens to be already in vertex form, so that's really cool because we don't really have to do anything other than, all right, trying to get this to go up there. All right. All right, so make that. So we've got 2x plus 1 squared plus 3, so y equals that. And if you think about it, it's the a x plus h squared plus k. So we want the vertex, right? And the vertex happens to be h comma k. Well, this when we pull out the h value, you know it has to change signs, and then the k value is exactly what you have. So when we draw this, we're definitely going to put at negative 1, 3. Okay, there's a dot. Now, The other dot happens to be your y-intercept. And back when we done the y-intercept, I said, hey guys, make sure you do this. As far as when you say y-intercept, right underneath it, x equals 0, so that you understand that the x value needs to go to 0. So substitute 0 in. 2 times 1 squared plus 3, so that gives me 2 plus 3, so the y-intercept is 5. There you go. And we know if this is 1 away, right? 1 away from the vertex, so 1 away on this side would be there. So that's what that would look like. So we have, and the answer, -1, 3, and then 0, 5. And they only want you to plot these 2 points here. There. So, and you would use this. You'd use this right here, this one. Because you're not doing a circle, you're not doing absolute value, you're not doing linear, you're doing a quadratic. So, all right. You needed, let's see. That was number 9. Did you still need number 10? Because number 10 is exactly like that, except there's a -1 there, and then the H happens to be a +1 when you pull it out. So you would have, let's see this.
I mean, if it's just like it, it's okay. Number 11, I'm having trouble with.
Oh yeah. All right. So, this, and we talked about this in class. Said find the vertex and then graph it, and at a convenient point, and then graph it. So if you think about this, is what it's doing a graph of a parabola with 2 points. So there's no linear term. So no linear term. It is both in standard and vertex form. Okay. So that's really saying this, right? And the A is 1. So if we're going to find the vertex, that'd be 0, 1, right? You can't change the sign on 0. So that'd be here. And what did it ask you to do other than that? Another point. Okay, Ben, I see. So you basically, I can choose 1. I could plug 1 in, right? So that's 1 plus 1, which is 2. So 1, 2 would be another point right here. And then that's all you need to graph it. But you just got to make sure that you understand, okay, hey, it looks like it's in standard form, right? But we need to find the vertex. And find the vertex, we normally do H equals -b over 2a, right? And then that gives me an x value. Plug it back into the equation, give me a k. But because there's no linear term right there, the equation is both ways. Okay. It can go in both forms. So.
Gotcha. Thank you.
Yep. Okay. What else?
Um, 13. actually had trouble with 12 and 13, but I guess if it's all kind of the same thing, then I'll just work it out later.
It is. It looks to be fine. The vertex may not contain integers, so be precise and be careful when using the graphing. 12 and 13, you said? Yeah, that's all you're doing. Okay, so you're going to be using I'll make sure you are kind of seeing what I'm seeing here. There. You're going to be using this graphing tool here, which means you've got to get the vertex and at least one more point. So that really tells you exactly how to set the problem up. I've got it in ax squared plus bx plus c form, and I need to put it, well, I don't need to put it in that form. I need to find the h and the k. So what I'm going to do is this, a equals 1, b equals 6. So -1, because that's negative b over 2a, is the h, right? So -1 times 6 over 2 times 1, so that's -6 over 2, which is -3, right? So that gives me the vertex. Well, not yet. It gives me the h value. Now I've got to plug it back in. 1 times -3 squared plus 6 times that plus 4. So this is 9 minus 18 plus 4. So it's -9 plus 4, which is -5. So a vertex is -3 comma -5. So that's going to be right here. Now I've got to find one more point. I don't have to worry about anything because this point right here, if you've got it in ax squared plus bx plus c, that's the y-intercept. So there's your other point right there. And you're done. Okay.
That's what I was having trouble with, finding another point to graph.
If you draw a blank, all you got to do is, okay, I know the vertex is at -3. Just plug in -2. Just do 1 times -2 squared plus 6 times -2 plus 4, right? You got an x, give me a y, right? And so that'd be 4. Yeah, that'd be 4 minus 12 plus 4. So that would equal -4. So that would be, boom, here. There's your other point if you needed that, right? So, but since it's in standard form, what I call standard form, where it's ax squared plus bx plus c, the constant there is my y-intercept. So as long as I found the vertex, which is via this, h equals -b over 2a, then I can just use that y-intercept and I'm done. Because, see, it only wants the vertex and at least one more point right there.
Can you draw it, like, in the homework, like, just so I can see how you draw it in there?
Yeah, let me grab these. Let's see. -3, -5. Okay. So -3, -5 here. And then 4 is there. There you go.
Okay, gotcha.
So that 4, the constant on this, because it's in the ax squared plus bx plus c, that's the y-intercept. So once I get that, boom, I'm done. So, all right. So that was 12. 13 is going to be the same way. Let me submit that.
Gotcha. I think it started like with problem 9 with the graphing, and I just,
yeah,
all the ones after that, I was like, if I can't do this one, I can't do the rest of them.
Oh, don't count yourself out like that. Come on now. So there, this is the same thing. It's just a different A, B, and C, right? But the C on this one, you got a point. There's 4. That's right there, right? So all I got to do is find the vertex, right? If I can find the vertex, let me go here. If I can find the vertex, then vertex and another point, it'll draw a parabola. So, yep. Okay.
Okay. And my last one was 18, and that's it.
That's it?
I know. I've struggled this week with this one.
All right. So, okay, this is pretty cool. So a ball is thrown in the air from the top of a building, right? So you're on the top of a building and you're throwing it up, right? Its height in meters above the ground is a function of time. So T is time. It's given by this. How long did it take to reach its maximum height? Round to the nearest second. So what you have to understand is the X, Y, that is time and height, right? So they want to know how long did it take to reach it? Round to the nearest hundredths of a second, which is 2 decimal places, right? So what they're wanting here is in standard form. So H equals negative B over 2A. So A happens to be, A is negative 4.9. B happens to be 24. So negative 1 times 24, because that's a negative 1 times B. So 2 times negative 4.9. So that's negative 24 over, what is 2 times? That's 9.8. So that's negative 9.8. And when I divide those, that's 24 divided by 9.8. A negative divided by negative is positive. So that comes out to be 2.4490. And because that, so we have 2.45 seconds, right? There you go. Done. And if they asked how high it went, see, this said how long. If it said how high, I would take that 2.45 and I'd plug it back in for T there, and I'd have it. So not only can I tell you how long it took to get there, I can tell you how high it went, which is pretty cool. So.
You say the 2.45 seconds is how long it takes?
Because see, you got
to reach
X.
The maximum height.
That's correct, because that's the H value of the vertex, right? And the H value is time, and the Y value, or the K, is height. They just said, how long did it take? So it's a time. But if they said, how high did it go? What was its maximum height? Then you'd have to take that 2.45 and plug it back in for T and get the K value, right? So just be mindful of that. You'll be okay.
Okay.
All right. Amy, you good? You just hanging out?
Yeah, I'm good.
Okay.
I'm sorry, Amy.
No, it helps me out to see this too, so I've still got a little bit of homework to do, so it helped.
All right. Aaron, I got that other online, but it wouldn't load up into it would not load up into Blackboard. I don't know why it wouldn't, but it just wouldn't load right. So I don't know if they were doing some maintenance on it or something. But I'll convert this one over into MP4 and I'll put that up. So it'll be up in about 30 minutes. It takes about 15-20 minutes to convert. So, all right.
Thank you, Mr. Palmer. Really appreciate it.
Yeah. Hey guys, we only have now this is going to be scary. Monday's last day of content.
Oh, that is scary.
And
that is insane.
And then Wednesday is final exam review. So the whole time I'll have you. Matter of fact, I need to find that email. It's got the problems to make sure you look at and get that out to you. But it'll be basically I'll be there and I'll just take questions off the final exam review. That's normally, I don't sit there and work. I just take questions. So if you, and that's what I'll tell everybody tomorrow. So.
Is that something we can print out?
Oh Lord, yeah. Yeah, it's a PDF and it's up in Blackboard already.
Okay, thank you.
So it should be underneath the online help sessions. It should say final exam review. And you just click on it. It should be three files. The final exam review, the final exam view with solutions, and then the formula sheet. Okay?
Okay.
So you can see what formulas they're going to give you on the final exam. So, and that's paper and pencil, multiple choice, face to face. And that's
And we need Scantrons for that, right?
Nope.
Okay, you already have that.
Yep, I got everything for you. All you got to worry about is bring a calculator and some type of writing, because you can do it with pen, magic marker, pencil. You can do this. Scantron can take anything.
Okay.
So you just got to worry about bringing a calculator in yourself and a
Okay.
writing device. So, and that's a week from Monday. Okay.
Oh boy. Okay.
So, and I'm pretty sure we don't have anything after our class, as far as I don't think anybody's taking a class after we get out at 8:20. I don't think anybody goes to anything else. So honestly, by the time we get started, let me do this.